So for this question, right, okay, when you approach a question like this, okay, look at the information. So if this is the diameter, okay, so is there an angle in a semicircle? We'll take a look. Okay, if we don't have, then let it be first. So, but how many sides do you have? 1, 2, 3, 4, 5. So this is a 5-sided figure. Okay, and then I will also take note of the radius because I can do quite a bit of isosceles triangle. Okay, then after that, we'll explore the question. So if this one has 5 corners on the circumference, sometimes you need to take note. You might have more than one possible cyclic quadrilateral, the 4-sided figure in a circle. Okay, so if you want to explore the first part, connect a line. Connect a line, and if you already have the indication of radius, you will see an isosceles triangle. So if you want to, you can do an isosceles triangle. Okay, so if you want to, you can do an isosceles triangle, you will get 18. In my answers, I never do it as an isosceles triangle. I do it as an angle at center and angle at same circumference. So because this one is at the center, so this one is at the circumference. And they are facing the same chord. So in my working, I never use the isosceles triangle, but you can use it. You will still get the same answer. So I'm using angle at center equal to twice angle at circumference. It doesn't matter. You will get the same one. Then the next one, ABD. So you actually need to cut across. Okay, so remember just now we have isosceles triangle to work with. So if you want to, you can like just find out whatever you can. And some people may get stuck for this if you never realize this is a cyclic quadrilateral. So there is a 72 here. So you could have found this one by doing an angle in the opposite segment. Okay, so the next one, we need to find out where is the location of F. So the issue will it be inside the circle, outside the circle, or on the circle? So we are going to explore it by doing something like this first. I think the easiest one will be you assume that it is on the circumference first, then you try doing this. So you try to visualize the angle on the circumference. If it is on the circumference, I think it's quite easy. You can see this part. So this one should be divided by 2. Can see? So if you assume that it is on the circumference, it will actually be a 72 because of angle center and angle on the circumference. But I'm not given a 72, I'm given a 70. Okay, so then you got to visualize what if it's inside. If it's inside, right, it looks like it will be more than 72. So that doesn't match this idea. So the only way will be F should be outside the circle. So when it is outside the circle, then it can go lower than 72. Okay, so how are you going to explain? You can just explain that if F is on the circumference or F is on the circle, then AFD should be this. And you quote the property. So your explanation must somehow be based on a certain property. Okay, so because it's 1 mark, you might not want to explain so much, but this one is critical. So after this, you can say something like, if F is inside the circle, you are expecting that the angle will be more than 72. You can logic out to explain. If it's outside the circle, so you paint the different situation, it should be less than 72. That means like 72 is your benchmark for explanation. Then after that, you finally conclude, since it is a 70, which is supposed to be less than 72, so it's supposed to be outside the circle. So this is a very detailed one for 1 mark. You can choose not to say so much. You can choose to say directly that it's outside, but you must say this part, because this is the one that is supported by a geometrical reason. So that's how we explain this 5a and the values that's connected to it.